Alright people, this is part 2 of section 3.5. So we're at the top of page 12 of your chapter 3 notes, and we have a practice problem here. So this is going to be very similar to the previous example at the very end of the last video at the bottom of page 12. It wants you to find the missing interior angle measurements. So you have a 5-sided object here, angle G is 80 degrees, and you have to figure out how big F and H are. So go ahead and pause the video and figure out that information, and we'll go over the answer shortly. Alright, let's see how everybody did. First thing you have to do is figure out what is the total measure of all of the angles together. So to figure out the sum of all the angles, we have to use the expression that we learned in the previous video, n minus 2 times 180, where n is the number of sides of an object. So we have a pentagon here that's got 5 sides. We should subtract before we multiply. And then when you multiply that out, you get 540 degrees as the total. Now I'm going to go ahead and use algebra over here to solve this. You wouldn't have to use algebra as long as you show your work and I can follow what's going on. It makes no difference to me. If you're using algebra though, we have angle F we don't know, so we're going to call that X. The next angle is 80, we do know that. The next one is another unknown. We'd rather not call it Y because that makes things really messy when you have two unknowns. Because these two things are equal, we can go ahead and use the same variable again as X. So that's a nice advantage for us. J is 90 degrees because you can see the little box there, and the same thing with E. And we just said that that's going to total 540 degrees. Now we're going to combine like terms. You have x plus x gives you 2x. Remember, that does not create x squared. X squared is created when you multiply x times x, and we're adding here. And then you also have like terms with these numbers. You have 80 plus 90 plus 90. And when you add them together, you get 260. And that's equal to the 540. We're going to subtract 260 from each side and get 2x is equal to 280. And then divide by 2, and x is 140. So that's the measure of angle F and the measure of angle H. Like I said, you didn't have to use algebra. You could, off the side, you could put 540, subtract it off the 80 that you knew here, subtract it off the 90, and subtract off another 90. That would leave you with 280, and you have to divide that by 2 to get 140. As long as you showed that work there, come up with the same answer, that's fine with me. Alright, moving along here to theorem 315. That is the polygon exterior angle sum theorem. So first we have to talk about what an exterior angle is. Common sense will tell you that's on the outside of the object, and that's correct. But what you want to do is you take a polygon here and you want to extend the side for just one of the two sides at each vertex. So here you have a vertex right here, a corner or a point, and we're going to extend one of the sides. Over here is another vertex. We extend one of them. We did not extend this one back and create some kind of crisscrossing shape, so we don't do that. You're just going to extend one of the sides at each vertex. So we have a 5-sided object here, and we have 5 exterior angles. So this theorem tells you that the sum of the exterior angles of a polygon, so we're going to put exterior in the blank line, one at each vertex, is going to be 360. Okay, so what this is this is exactly opposite of the idea of the interior angles. We said the interior angles, you have to use that little expression n minus 2 times 180, because every time you add a side, you add more degrees to the total, or the sum of all the angles of the object. Here, the total is always going to be 360 no matter what. So you could have a 3-sided object, you could have a 100-sided object, you could have a 20-sided object. You draw all the exterior angles, one at each vertex, add them all up, you're going to get 360 degrees no matter what kind of object you're dealing with. So based on our little diagram here, we can tell that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 is 360 degrees. It would be the same deal with the triangle, except for you only have 3 of them here. You have angle 1 plus 2 plus 3 is 360. Or a 10-sided object would have 10 of those angles added up to get 360. So let's see that idea in action. We're going to verify it using a triangle. Pick the triangle because there's only 3 sides, and only 3 vertices, which means there's only going to be 3 exterior angles. So it'll be the quickest way to show how this works. Here you have a triangle with all three interior angles given to you, and each side is drawn long enough so it creates one exterior angle at each vertex. So when we figure out x and y and z and add them together, we better get to 360. Right? So to figure out x, we see what these two right here are adjacent and supplementary. So we can take the 180 minus the 95 and subtract there, and we get 85 degrees. And that is going to be your x. And we're going to do the exact same thing to figure out z and y. So z is 120. And for y, you subtract 180 minus the 25 to get 155. So now here we have our three answers, 85, 120, and 155. And it says verify that their sum is going to be 360. So if you take the 85 and the 120 and the 155 and you add them all up, sure enough you get to 360 degrees, which is what the total is supposed to be. Right, and it would work the same thing with a 4-sided object, but you just have 4 of these, or a 10-sided object, but you'd have 10 of them, but you'd still be adding up to the 360 no matter what kind of polygon you're talking about. So right there it says in big letters for us, the sum of the exterior angles is 360 for any polygon. And a couple vocabulary words, most of which you've heard before. A polygon that has all the sides congruent is going to be equilateral. We've used that for years with talking about a triangle with 3 equal sides is equilateral, but if you had a pentagon with 5 equal sides, it would be an equilateral pentagon, so on and so forth. A polygon that has the angles equal is going to be equiangular. And I think we've mentioned that before. It's usually a new term for kids in geometry. You don't hear about that before, but I think we've mentioned it earlier. Equal angles, you can see it's equal angles. You could practically see the idea right there in the word. Equiangular means all the angles are equal. So if you have a hexagon that has 6 equal angles, it's going to be an equiangular hexagon. And then the last idea is something brand new. When you put both of those ideas together, they call that a regular pentagon. So a regular polygon, excuse me. So a regular, say, hexagon is going to have 6 equal sides and 6 equal angles, both, not just one or the other. All right. So when they say a regular octagon, you know it's going to have 8 equal sides and 8 equal angles. Okay. Flipping over to page 13. Example 5. It says draw an example of each using quadrilaterals. So quadrilaterals tells you how many sides you're going to be shooting for. You're going to draw one that is equilateral, so it's going to have equal sides. Equiangular, it's going to have equal angles. And regular, so it's going to have both of those ideas. And I will tell you this, there's a couple ways of doing this one, there's a couple ways of doing that, but there's only one right answer at the end. Okay, so go ahead, even though this is not a practice problem, go ahead and pause the video and draw one of each. And put the little symbols on the drawing showing equal angles or equal sides. And we'll go over the answers shortly. Right, equilateral. Equilateral means same sides. They want us to use quadrilateral, so you're talking about a 4-sided object. So one way you could do it is to draw a rhombus. A lot of people casually refer to that as a diamond. And it's got 4 equal sides, so you need to have 4 dashes. You also could have used a square there, because a square's got 4 equal sides. That would have been just as correct. Equiangular. One thing you could have drawn is a rectangle. Since a rectangle's got those 4 90-degree angles, we know that 90-degree angles are always going to be equal to each other, so that guarantee that's going to be equiangular. The other way you could have drawn that is, again, you could have drawn a square, because a square's got 4 90-degree angles, so it would automatically be equiangular. Now regular, we have to put both those ideas together. We have to have an object that's got 4 sides, 4 equal sides, 4 equal angles. So the only thing that really works there, as I'm sure you probably have drawn, is a square, because it's got 4 equal sides and it's got 4 equal angles. Right, so that wraps up for section 3.5, and you can see that next time we're doing on the next section here, we're talking about lines and coordinate planes. This section here has an awful lot of old algebra in it, so that should go smoothly. We'll talk to you later.